And my remote people, what we're going to do today, I gave the in-person folks a handout to write on, so you're probably going to want to do the practice on a separate sheet of paper, just because it's not something that can be done. You're going to still turn it in online, but it's not something that can be done online because we're drawing. All right, so let me get it focused. That is not your guys' stuff, though. Okay. And then we need. All right. So let's go ahead and get these notes done real quick, and then we're going to do about 800 practice problems. Not actually 800. It's just going to feel like a lot. There we go. Okay, so we're going to pick up where we left off and talking about covalent bonding. And all we've done with it so far has been learning how to name them. And then we talked about the difference between like a double, a triple, a single bond. So a couple of other things as far as looking at covalent molecules, and then before we get started on the drawing part. One thing that gets considered a lot is the bond length. So since the electrons are shared between the two atoms, and therefore the electrons are moving back and forth, the distance between the two atoms is going to be important. All right? So this is the distance between two bonded nonmetals. Because remember, covalent molecules, nonmetals. Let's not write that. Nonmetals. Because remember, covalent molecules only involve nonmetals. So it's the distance between the two, and how far apart they are is partially related to how big the atoms are, but it's also related to how many pairs are shared. Okay, so the more pairs of electrons are shared, the shorter the bond's going to be. All right, so what that means is that the single bond will be the longest. And the triple bond will be the shortest. And then double will be between the two. Okay, so the more pairs of shared electrons in the bond, the shorter it's going to be. Okay, the other thing, and it's kind of related to that we look at with covalent molecules is the bond strength. And the reason that that's important is that the stronger the bond, the more energy is required to break it, which kind of makes sense. And that's important because in our next unit, we're going to actually start talking about chemical reactions. And one of the things that has to happen in a chemical reaction is bonds have to be broken. And so as we're looking at breaking those bonds, the stronger the bond is going to require more energy in order to make that happen. Okay. So same kind of along the same lines as the bond length, the more pairs of shared electrons, the stronger the bond is going to be. So what do you think will be the strongest bond? A double or a single, a double, or a triple? Triple is going to be the strongest, okay? Because there's 3 pairs of shared electrons, as opposed to just 1 or 2 in the single or the double. I can't spell today. Strongest. There we go. And then so the single bond, if you're comparing like single to double to triple, is going to be the weakest. So to kind of sum that up, triple bonds are your shortest and strongest bonds. Single bonds are your weakest and your longest. And then double bonds fall in between. Yeah.
Are we still doing that extra code thing?
Yes. Wait, what did I decide to do? Yes, we are. I came up with something we're going to do. I'm glad you said that. Yep, thanks for the reminder. All right. So that's kind of all of the like last little detail material we had to do. What we're going to work on now is learning how to draw what are called Lewis structures. All right, and Lewis structures are drawings, and we kind of refer to them as models, even though they're not like 3-dimensional models you can hold in your hand, that show the bonds and unbonded valence electrons in a molecule. Okay, so for this, I am going to give you the steps for drawing a Lewis structure and then give you time to write them down. And then we'll work through how to do them because it does me no good to explain while you're writing because listening and writing at the same time is difficult. All right, so here's step 1, how to draw them. Put least electronegative.
Does this say except H?
Except H, yeah, except hydrogen. Hydrogen can never be in the middle. Hold on. I'm gonna need more room. This is the last. No, the hardest part is just remembering all the steps. But if you can get the steps down, they're easy. Okay, give you a second to write all that down. All right. Anybody need more time writing them down? All right. So we're gonna do a lot of examples on these, and then I'm actually gonna do some of the ones you're gonna have to practice with you, because it just takes a while to get used to the process. So you're gonna be given a molecule, like this one is CF4. All right. And what you're gonna need to do is follow these steps to draw the Lewis structure for that. Okay. So the first thing you're gonna do is you're going to put the least electronegative atom in the middle. So do you guys remember the trend for electronegativity?
Up and to the right.
Up and to the right. So if you want the least electronegative, you want the farthest down and to the left, okay? So of these two, carbon and fluorine, which one has the lower electronegativity? Carbon does, okay? And you'll find a lot of these are going to have carbon in it, and carbon is almost always, and for you guys always, going to be in the middle, okay? Because carbon can form 4 bonds. So we're going to put carbon in the middle. So I'm just going to give some space around it, and I'm going to write carbon down, okay? Now, the next step, step 2, it says to count total valence electrons. So it's been a while since we did this on the periodic table because we've been doing charges for so long. But the valence electrons kind of go with the groups. So how many valence electrons does group 1 have? Okay, so that has 1. How many does group 2 have? Okay, and we're not going to be dealing with any of these either. What about group 13? Not 13. 3, 14, 4, 15, 5, 16, 6, 17, 7, and then 18, 8. Okay, so you're going to use those numbers to count up the total valence. So carbon has 4. All right, so there's 4 valence electrons in carbon. And then how many is there in fluorine? 7, but we have 4 fluorines. So I'm going to multiply that 7 by 4. Okay, so here's some math. This is fun. 7 times 4 is 28 plus 4 is 32. What that means is I have to have 32 total electrons represented somehow in my drawing. So that's an important number. All right? So that's step 2. Step 3 says bond the other elements to the central atom. What that means is I'm going to take the other elements that are present, which are just fluorines, and I'm going to bond them to the middle carbon. All right? And how you arrange them is not a huge deal at this point. All right, so I'm going to just put 1 here. I'm going to try and space them out evenly just because I'm OCD like that. It probably won't work because I'm not as good at that. So I'm going to space them out like that. If you wanted to do 1 on the top, 1 on the bottom, and 2 on the sides to make like a plus, that's fine. We're not worried about it right now. Okay, so that's step 3. You just write the other elements around and you connect them with a line. The line represents a bond. Okay, that bond is the 2 pairs or 2 shared electrons in a pair. Okay, now what I'm going to do is the next step where I'm going to add dots, which are going to represent valence electrons until each atom has 8. Okay, because you remember that whole goal is to have 8 in your outer shell. All right, now the central carbon has 4 bonds around it. If each of the bonds represent 2, it already has 8 electrons around it. Okay, so the carbon doesn't need any dots. The fluorines, each one has 1 bond around it, which is representing 2 electrons. So if it has 2 around it, it's going to need 6 more to get to 8. And I'm going to add the dots in pairs, kind of like we did with the dot diagrams. So I'm going to put 1 pair here, 1 pair here, 1 pair here. Okay, and then so that's 1, 2, 3, 4, 5, 6, and then my bond is 2 electrons, so that's 8. You get to count the bond for both atoms because they're sharing it. All right. Now each of the fluorines is going to need 6 more electrons to get to 8. So I'm going to go ahead and add 6 more dots to each one. You'll get tired of drawing dots. This is why we're not doing it on the computer. All right. And so you wind up with something that looks kind of like that. And then my next step is to count up the total electrons shown in my drawing, because I've got to make sure that my drawing shows all 32. All right, so let's count them up. 2, 4, 6, and then your bond counts as another 2, so that's 8. 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Now, if I have this number, then I'm done. and I don't have to do either of these two things. Okay, so since we have 32 represented, we're done, and that is our Lewis structure. How do we feel? It is a lot of steps to get used to. So let's do 800 more. Let's see. Let's do NH3. NH3. Okay, so step 1. What's going to be my central atom here, N or H? N. H can never be in the center because hydrogen can only form a single bond. It's going to be one of the ones that you don't try to get 8 electrons to. Okay, so nitrogen has to go in the middle. So step 1's done. Step 2, count up valence electrons. So go find nitrogen on your periodic table. So 5 electrons for nitrogen. How many for hydrogen? 1, and then I gotta multiply that by 3 because there's 3 of them. So how many total electrons do I need to have in my drawing? 8. We're only multiplying the 1 times the 3. There's only 1 of the nitrogens. Yeah. All right, so then that's step 2, count total valence electrons. Now we're gonna just put,
So where does the bond from?
Nitrogen is in group 15, so it's got 5 valence electrons. All right, so now take the 3 other hydrogens, and we're just going to connect them to the nitrogen with a little line, and however you want to arrange them is fine. Okay, so if you want to put like the 3 coming out the top, or we're not worried about it. Okay.
So every little bond is worth 2.
Every line's worth 2.
It's worth every 2, no matter what bond it is.
Now, like if it were double, then each of the little lines would be 2, so it'd be 4 total.
So like you draw 2 bonds.
Yeah, and we'll do several with double or triple bonds here in just a second. Okay, so now we're gonna add dots to represent valence electrons. But listen to me on this: you will never add dots to hydrogen, never ever, because hydrogen can't actually have 8. Okay, so this is kind of way throwing back to like electron configuration. But hydrogen only has 1 energy level, and the first energy level can only have how many electrons? 2. So hydrogen can only have at most 2. So we actually do not add any dots to hydrogen. Ever. Okay? So the only thing I need to worry about getting to 8 is the nitrogen. In my drawing right now, how many do I have around my nitrogen? 6, because each of these bonds is 2. So I just need 2 more dots on the nitrogen. So I'm going to put them somewhere that I don't have a bond. Okay? I'm going to add 2 dots. Yeah.
So what does this show? Like how we use this?
Okay, so what we're going to learn how to do next is how to tell what shape it is. And we're actually going to build 3D models of what these molecules look like in real life. Like if you could actually look into the molecules in the air and see what oxygen looks like.
So that N represents what, an atom?
Yes, that is an atom of nitrogen, and it is held together to 3 hydrogens by that bond. Okay.
When you say we're going to build a 3D bond?
Yes, well, not like with actual atoms, because obviously those are way too small to do anything with. But we have these shape kits, and we're gonna actually construct what it would look like if they were big enough for us to see.
Wait, can hydrogen have like a double bond?
Hydrogen cannot double bond. It can't double bond. It can't triple bond. It can't have any dots. Its life is boring. It's not the only one like that. Helium's like that too, because it's also first level. And then there are a couple of other exceptions that don't have 8. But we'll talk about those later. That's a problem for future you. Yeah.
So like the bottom 2 rows, those
like the 2 at the very, very bottom.
Yeah.
You won't have these for those because those are metals, and these are only going to be involving nonmetals because they're all covalent. Good questions though. All right, let's do some more. So let's do Let's draw oxygen. Speaking of, let's see what an oxygen molecule will look like. So let's draw O2. All right. Now, if you only have 2 atoms, it doesn't matter which one goes in the middle, okay? So we're going to kind of combine a couple steps for these, and we're just going to put the 2 oxygens next to each other and connect them with a bond, okay? Because if you only have 2 things, there's not really a central atom, all right? But let's go ahead and count up our valence electrons. So how many valence electrons does oxygen have? 6. And if there's 2 of them, how many is that total? 12. So you've got to have 12 in your drawing. Okay, so I've got an oxygen bonded to an oxygen. So now my next step is to go and add dots so that everything has 8. All right, so each of those oxygen gets to count 2. So I'm going to add 6 more dots to each one. It does. So that's the next thing you have to do. So remember that last step is to count and make sure it equals this. So that's 2, 4, 6, 8, 10, 12, 14. Okay, so go back and look at those like bottom steps I showed you. Where if you have too many, what we're going to do is make a double, or if you need to, a triple bond. So here's how that works. If I'm going to double bond 2 atoms, I'm going to erase a pair from each one. So like I'm going to erase this pair of dots, and it doesn't matter which ones, and this pair of dots. Okay, I mean I whited them out, but you'll probably have a pencil. So then, once I erase 2 pairs, I can make 1 double bond. All right, so let's check and see if we have 12 now. 2, 4, 6, 8, 10, 12. So that's how you figure out if they have a double or a triple bond, because the number of dots will come out to be too much. Okay?
Well, I got one question.
Yeah, no, keep asking. Valence electrons. Yep. So let's do another one kind of like that. Let's do N2, which is nitrogen, which is like 70-something% of our air. All right, so again, if you have only 2 atoms, there's not really a central one, so you're just going to kind of connect the 2. All right, so let's count up valence. How many valence electrons does nitrogen have? 5, and there's 2 of them, so how many total in my drawing? 10. All right, so I'm going to add dots so that everything has 8. So it's got 2 to start with, so I'm going to add 6 dots. And as you're adding these, you can probably already tell it's going to be too many. But sometimes going through the process is helpful. So if I have that, I've got 2, 4, 6, 8, 10, 12, 14. Okay, so I'm going to have to double or triple bond. So I'm going to erase a pair from each. And let's try a double bond and see if that's enough. Does that give me 10? Nope, that's still 12. That's still too many. So then erase another pair from each atom. And now we can make a triple bond. And so then 2, 4, 6, 8, 10. Okay. All right, so let's do some more complicated ones since we're doing so good. Let's do HCN. This is hydrogen cyanide, or cyanic acid, hydrocyanic acid. Okay, what do we think is going to be the central atom in this one? It's going to be carbon. Obviously, it can't be hydrogen. And then between C and N, carbon's the farthest to the left. And if you can't remember that, your best bet is just always put carbon in the middle. All right, then let's count up my valence electrons. How many from the hydrogen? 1. How many from the carbon? 4, because it's in group 14. How many from the nitrogen? 5. What is that total? 10. So I can have 10 in my drawing. All right, now I'm going to go ahead and connect the H and the N to my carbon. Doesn't matter what side they're on. So if you have yours flipped, that's okay. Remember, these are three-dimensional molecules, so even though we're drawing them on paper, they are like 3D things. Okay, so then we start adding dots to get to 8. Do I add any dots to hydrogen? No. Carbon, it has 4 around it with the 2 bonds, so I need 4 more dots. So I'll put a pair on the top, and I'll put a pair on the bottom. And then the nitrogen right now has 2 around it, so I'll put 6 more dots, so 3 more pairs. All right, and then as tempting as it's going to be to just skip the whole counting up and making sure step, do it anyway. So 2, 4, 6, 8, 10, 12, 14. That's too many. So I'm going to need a double or maybe also a triple bond. So remember, you can't double or triple bond a hydrogen. Also, there's no pairs to erase anyway. So it's going to have to be the carbon and the nitrogen that you do it with. So I'm going to take a pair from each one. And let's try a double bond and see if that's enough. Okay, so 2, 4, 6, 8, 10, 12. Still too many. So repeat that process. So take away another pair from each one, and let's try a triple there. So 2, 4, 6, 8, 10. And that's good. Well, what it is each of the carbon and the nitrogen get to kind of have 8 in their outer shell. Even though these are shared, so the carbon has 2, 4, 6, 8 that it gets to count. The nitrogen has 2, 4, 6, 8 that it gets to count. But you only count them once.
What if, like, when we got 10, well, what if that equal 8? Like, we had to get to 8.
Oh, that wouldn't be possible. No, there's no such thing as like a quadruple bond or anything. Not that we know of yet. We're still figuring this out. All right, let's do this one. Let's do H2CO. All right, what do we think is going to go in the middle? Carbon. It's always your good bet there. So carbon in the middle. For you guys, no. If carbon's in the molecule, it's going to be in the middle. All right, so count up your valence. So hydrogen has how many? 1, but I got to multiply that by 2 because there's 2 of them. How many from carbon? 4, it's in group 14. And then the oxygen has how many? 6, because it's in group 16. Yeah, so add that up and you get 12. And feel free to punch that in on your calculator. Please don't miss a problem because mental math is not your thing. Okay. All right, so now we're going to connect the 2 hydrogens and the oxygen. And where you do that does not really matter. I'm going to do it like that. However you want to, it's fine. I'm just an evenly spaced kind of person. All right. So now we need to add dots. Do we add any to hydrogens? No. Nope. So let's look at carbon. How many does it have around it right now? 6. So I need another pair of dots somewhere that you don't have a bond drawn. And then how many does the oxygen have around it? Only 2 right now, so I need 6 more to get to 8. So we're going to add 3 more pairs of dots. All right, and then we count to see if we have 12. So 2, 4, 6, 8, 10, 12, 14. So what do we do? Yep, we're going to take away a pair from the carbon and the oxygen. So, and hope that that works because there's only one pair to take away from the carbon. Make a double bond. And so then you've got 2, 4, 6, 8, 10, 12. All right. Let's do one more, and then I'm going to kind of guide you guys through some practice. We're going to do some where you have to add extra. So let's do SF4. Okay, so what do we think is going to go in the middle? Sulfur. And you'll find that like fluorine and chlorine, those can't go in the middle because they can only form one bond. They only have one electron. Yeah. Least electronegativity. Least electronegativity goes in the middle. Yep. So, and on these, if you have only 2 atoms, it's going to be the one that there's least of. So that's kind of a helpful thing as well. You'll find very few instances where a noble gas can be in one of these because usually they don't bond at all. In the rare instances that they have made bonds, sometimes they're in the middle. Depends on what they're with. But they've only been able to make that happen like in the lab, like as a synthetic compound. No, because they already have 8 around them, so they really don't want more. All right, so let's count up valence. So how many does sulfur have? 6. And how many does fluorine have? 7. And then you've got to multiply that by 4 because you've got 4 fluorines. So 7 times 4 is 28. And 28 plus 6 is what? 34. Again, don't be ashamed if you have to punch that in a calculator. All right, so now we're going to add 4 fluorines to my sulfur. Wherever you want to add them's fine. That was terrible spacing. Anyway. All right, then let's start putting dots. So right now, as I have it drawn, the sulfur has 8 around it. So I'm not going to add anything to that. So I'm going to go and kind of like that first one we did, and I'm going to add 6 dots to each of the fluorines. Because the bond around it is already giving it 2. So each one's just going to need 6 more dots. Yeah. So each of these is representing 2. The lines represent 2. All right. Okay. Then let's count them up. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Okay. So look at the other, like, if statement. Yeah.
The sulfur came in that
You know, you would think. You would think it can't have more than 8, but some of them can have more than 8. Okay? If they are in the 3rd row of the periodic table or below, which is why it says 3rd row and down, they can do what is called an expanded octet, where they can access lower orbitals to bond. Okay? And you don't have to know, like I'm going to explain once we get into like the building the bottles thing, how that works, like why they can do that. But for right now, if they are 3rd row or lower, then they can expand their octets and have more than 8. Okay? So if you do not have enough in your drawing, and your atom will be in the 3rd row or lower, if that happens, you can add extra pairs to the central atom. So I have 32, but I need 34. I'm going to add an extra pair of dots on my sulfur. It's really like learning grammar, where you learn how to do it, and then there's like 18 exceptions. Like, well, if it's third row and lower, it can have more. If it's hydrogen or helium, it has to have less. It's a whole thing.
So you can't have an extra bond.
You can only add extra dots, but you could have extra bonds. So let's do PCl5. I'll show you. You can do both.
Wait, so it's third row or higher?
Lower.
So it's third row or lower?
Mm-hmm. Because it has to have access to those that D sublevel is why. All right, so PCl5 would have phosphorus in the middle. And then because phosphorus is third row or lower, it wouldn't make sense really to have 4 chlorines and then another chlorine bonded to one of the chlorines. Because chlorine can only form one bond because it only has one valence electron. So what we can do in this case is put 5 chlorines. Oh, sorry, I didn't mean to say one valence. It needs one more. That was my bad. Okay, so, and if you were doing, if this was like NCl5 is not a thing because nitrogen can't do this. It has to be third row or lower. So we're going to put 5 chlorines around that central atom. And we're getting into some wonky ones here. So let's count up valence because I forgot to do that. How many in phosphorus? 5. Chlorine has,
7.
and there's 5 of them. 7 times 5 is 35, plus 5 is what? 40. So then if we go and add dots to each of these chlorines, oh, that's too many. Ignore that. Are you tired of drawing dots yet? Fair enough. Fair enough. All right, so if you do give each chlorine 6 more dots and then count, you'll find that it equals 40. Okay, so you can have more than 8 if it's third row or lower. You can have less than 8 if it's like hydrogen and helium or a couple others that I'll tell you about later. But that's kind of where we're at. So let's go do some of your practice, and I will work with them alongside of you. Give you a chance to try them now. Now there's a couple I'm going to have you mark out on here. It may just be one. All right. So my online people, this is what's in the interactive notebook for section 10. And but if you just want to draw these on a separate sheet of paper and upload a picture, that's what I'm going to have my in-person people do. All right, before we start doing these, find the one that says C2H6, mark that out. And then kind of 2 underneath C2H4, mark that out. We're not going to worry about double central atoms right now. Okay. So I want you guys to try and work through these. A couple of them we've already done, like maybe 4 or 5 of them. Okay, so some of them we've already done, but see if you can do them, and I will be putting them up here as well so you can check. Okay, stop when you get down here to SO4 -2 and PO4 -3, because I'm going to show you how to do those probably tomorrow, because I don't think we'll get finished today. So don't do the bottom 2 on the right-hand corner yet. Wait until tomorrow for those. All right. So try these. The first one will be the easiest one. Oh yeah, that's fine. I could have signed it. For both. Here you go. And if you want to go ahead real quick and fill in the ones we did, that's fine. So let's see, we did this one. And we did this one. And we may not have time to get to that extra credit thing today. If not, we'll do it tomorrow. I won't forget about it.
Is that how you do that, or do you have to get rid of it?
Yeah.
That's right.
Mhm.
Okay. So if it's just hydrogen right there, and you have the 2 right there, and you have to get, if you have to keep adding them, you don't put too many away. You have to take away.
Right.
But if it's something you can put, if it's something that has other dots, you put more than you take away.
Right.
And put a
Yes.
double bond or a triple.
Yeah. If you have too many. Yep.
Okay.
Did you say hydrogen whenever they have a center?
Yes.
Okay, so on HOCl, would it be,
So on that one, the O is gonna go in the middle.
one's lower, but the other one's farther to the left.
Yeah, and on that one, if you put CL in the middle, I'd still let you count it. But O is the better one to put in the middle because CL usually doesn't form more than one bond. But if you did, I'd give it to you. Let's see, what other ones did we do? We did the NH3. So here's the answer to the first one. That's it.
I have another question.
Yeah.
So on the HOCl,
Mm-hmm.
there's not enough, but it's not third row or lower.
Okay, let's see. You should have enough. So it's 1 plus 6 plus 7. That's 14.
Oh, I didn't put those in.
Okay. It's easy to forget with the central one.
So how many dots are
Well, it's got 2 bonds, so that's 4. So you need 4 more dots total to get it to 8.
Oh, so the central one always has to have 8?
Yes, unless it can have more or less. Yeah, unless it doesn't. But yes, you want to shoot for 8 for most things. Mm-hmm. The carbon has 4, and then the hydrogen has 1 each, so that's 4 more. Yeah. Mm-hmm. No, there's just 1 carbon in the middle, and then you're gonna have two H's and 2 Cl's. So O is gonna go in your middle, and then 2 H's, and then you need 2 more sets of dots on the O. And so that's 2 plus 6, that's 8. 2, 4, 6, 8, yeah. It does, but then you've got the 1 from each of the hydrogens.
Oh, okay.
Yeah. No, you're good. Takes some getting used to do these. Oops, sorry, Eve. I just saw that. That's my bad. That's my
You
bad.
always put dots on T,
Do I always put dots where?
like the center. So like carbon.
You only add dots if it doesn't have 8 around it already. Like in this one, it's got 4 bonds and each is 2, so that's 8 already. So I don't need dots on that. It's carbon. If it had what?
So it doesn't have like one bond.
Yeah. Yeah.
Does this one supposed to have double bonds on it?
Mm-mm.
So how would you get to 20?
So when you add dots, or so you have the 4 things, and then you add 6 dots each to chlorine. So that's 2, 4, 6, 8 from the bonds, and then 10, 12, 14. Wait, 2, 4, 6, 8. 10, 12, 14, 16, 18, 20.
Okay, because I had put some around this so I could get to
Yeah, since it's already got 4 bonds, that already counts as 8 because those are 2.
Oh, okay.
Yeah.
So if it has 2 bonds like this, you add 2
Mm-hmm.
for it to get.
To get to 8 because those are 2, so you need 4 more.
Okay.
Yeah.
So, but if it already has 4, you don't put dots.
Right.
Okay,
Mhm.
that makes sense.
Yeah.
It's really weird. I'm not sure if you're supposed to get too much lip there at first.
You are at first, and then you'll have too many.
Okay, I just want to double check. So, like, do you make sure it always equals like, 10 fast?
Mm-hmm. And then if you need to adjust for double or triple, do that.
With what?
Yeah. Okay, CO2 you'll need to fix because carbon doesn't have 8 around it. And then that one's good, that one's good, that one's good. And then 28 plus 8 is 36, 32. Yeah, you got 2 pairs of dots. Perfect. Okay, you've got too many around the sulfur because that's 2, 4, 6, 8, 10. And it can add more than 8, but in this case it won't. But other than that, it does too. Yeah. Mm-hmm.
So this isn't a clip on the
No, because your carbon doesn't have 8 around it. It's only got 2, 4. The way it's drawn. So like I'm doing it now. So I did this, but that's too many. So then I'm gonna do my double bonds.
So on mine would I just do 2 dots?
Mm-hmm. And then try and get your double bonds where you need them. So we'll do that pair. That one. Why not? So double bond this. And then we'll do that pair. And this one. And then we'll make that. Sure.
What's CO2 different? Like that. I'm still ending up with 16. I don't know.
So the reason this one doesn't work is because your oxygens don't have 8 around them.
The oxygen.
Because it's got 2, 4, 6, so you would need another pair of bonds.
I thought oxygen had 6.
They have 6 valence electrons, but remember when they bond, the whole point is to get to 8. That's why you have to add dots so that everything has it.
So everything is it?
Mm-hmm.
Those are
Mm-hmm.
but so that's drawing.
Yeah, because you can't, because carbon can't have 1, 2, 3, 4, 5, 6 bonds. Because that's too many, because it can't have more than that. Which one? I think you've still got one too many. 2, 4, 6. Yeah. So do one more double bond, then you got it. When you're counting overall, yes. 2, 4, 6, 8, 10, 12. Still too many. Yes.
On this one, is it not 2, 4, 6, 8, 10?
So remember that everything's got to have 8. So you would need another pair of dots on each one. And then that gives you too many. So you want to get to 8 for each one. Um, 21, 22, 26.
What Regis said you can do, it's like, it doesn't have no mistrust.
Yeah.
Regis said you can, it doesn't have no,
Which one? Okay, since xenon is first row or third row or lower, you can add a pair of dots or 2 to the central atom.
Okay, well, because I didn't think, so I sat up
Right.
and I think I got the 30 or 30.
Yeah. And so you'll need 2 pairs of dots added to XE.
And then we don't do the bottom 2 squares.
Yeah, don't do the last 2. We'll do those probably tomorrow.
Sulfur and oxygen, but sulfur being
Group 18, that last group.
sulfur being
Yeah. So that's, let's see, 8 plus 28. If you're done, you can take a picture of it and upload it to that interactive notebook for section 10. Oh wait, we still have to do the last 2, so just sit tight. Or we're probably done, you're probably done for the day. I don't think we'll get to the last 2.
And then on this section, you have to resolve what is solved to what are sulfur or what are
1820. Too many. Too many.
You still want us to submit it to
Wait till tomorrow because we've got to do those last two for polyatomics.
Okay, so we don't.
Not yet.
You had like these two double bonded. But it are like this.
But your carbon doesn't have 8 around it.
Oh.
Yeah. That's easy to forget. Okay, so tomorrow we will do these last, I'll show you how to do the last two, and then we'll do the little extra credit thing, which is just more practice with this, okay?
So we can do stuff on the back.
Mm-hmm.
How we
Or just move the 3 of us. So like if you every
No, on this, what you have to do is count up your valence electrons, but then you have to add that many to it. Like add 2 extras, add 3 extras.
even if it's a negative.
Yeah, because when negative means adding, yeah. Yeah.
So right here,
hmm
I had to make it up.
So remember, you don't add dots or double bond to hydrogen. Yeah, that's what's messing with you. Not yet. We'll do it tomorrow. Yes, at
If
least
it's just
8.
like if it's just 2, it doesn't have to be 6.
It would need to have 8 unless it was something like hydrogen or you had a double bond over or something like that. Okay, yeah.
It's like if you're trying to get it, it's like for
Uh-huh.
like how do you know when the place that
So before I put those dots, I counted up everything and I only had 32, but I'm supposed to have 36.
so you just add it?
So I added 4 more to the central atom. Yeah. If you're not gonna finish in class, take a you might want to screenshot this so you can check your answers at home or something. If you're not gonna finish in class, except for the last 2, we'll do those tomorrow. You've still got like 13 minutes. Yeah. I mean, you could just set it on that little desk in the back hallway thing behind where Cadence is out. I usually do, but this year since we haven't done paper, I haven't kept folders. Yeah. Yeah, so this one, originally, let me show you what mine looks like. After I added all my dots and everything, it looked like this when I gave everything 8. But that's too many because you can only have 16, and that's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So then I took away a pair of dots from this carbon and this oxygen, and I made that a double bond. And then I did the same thing with the other one to get it to 16. So obviously we won't have a quiz on this tomorrow. But the nice thing is when we do, it'll just be can you pick out the right one? So you won't have to draw them. So maybe that helps. Because everything's got to have 8. Most things have to have 8. That's why we go and add dots to get everything to 8. So it has to be done even for the central atoms as well. Yeah.
Where would I go from there?
Like after this.
Yeah, where would we go?
So now each of those fluorines has 1 bond around it, so that's 2. So you need to add 6 more dots so that each fluorine has 8 around it. And if you count from there, that's 32. And you need 36. So because xenon is 3rd row or lower, you can add 2 extra pairs of dots on the XE so that you can get 36.
Okay, but I don't understand. So, what is the middle? Does it ever have anything like that?
What do you mean, like?
Like, so this is carbon and that's 4. So does it start with 4 or is it? I don't know.
Well, you're gonna, the 4 is just how many valence electrons it's contributing. But before you double bond and everything, you have to make it have 8. So to start with, the carbon only has 4 around it from the 2 bonds. So you would have to add 2 more pairs of dots to get it to 8. And then when you do the same thing with the oxygens, you'll find that it has too many overall, and so that's why you have to go and double bond. Okay.
No, it's not black. Oh, she's here.
Probably not. Yeah.
Glue.
We don't have soil.
Joe, actually, today was 16.
Yes.
I like Monday. Yeah.
It makes sense. Look it up. Maybe she actually will get. Let's ask her what. And you're just so sorry.
You have to have it equal.
Well, you just have to have it equal to 36. So the way it's drawn now, the F, like all around the S, is 32. And so you need 2 more sets of dots.
I can't go. She doesn't have much else.
You don't like that. The best outlet.
You don't know who's like
I'm getting away.
I know about the but everybody. See, but I know about students. Yeah,
Yes, the butterfly.
it's like when you go like this. You know what?
Yeah, so the freestyle. Oh, you can always do back.
You know that. Yeah. Like you're pushing. I mean, did what if you got get in trouble? Press, go get over that. Yeah, underwater. It's like when you go in one.